Yeah, hi. I've gotten quite a lot of questions on how MDriven Turnkey actually work, so I'm gonna do a short presentation of the architecture behind it and what it does. So we have a database that has tables and tables that has columns, and some of the columns are interpreted as associations, like that. And we preferably use MS SQL, but we can also do MySQL and a bunch of other backends, database backends as well. But with Turnkey, we only offer these two as the standard implementation. And from here we have a domain layer that is in the application, and the domain layer use information classes, typically in C#, and these have associations as well, but and attributes that corresponds to the columns. But they also can introduce or have a representation for inheritance and derivations and a bunch of extra things that's available when we raise the abstraction from a simple ER diagram to a model. Yeah, and from here we do some folding of information perspectives, and this is what we call the view models. So the view model is a piece of information that's needed for a particular perspective on the model, to do something, to produce something, or whatever. And have you used MDriven Designer, you know that we like to associate the view model columns with UI hints that display some label and some UI widget, how it could look in a UI if this view model was a UI. This is optional, but leads the thinking right. So it's some kind of UI widget to edit an attribute and some grid to show objects. But the view model can of course navigate the domain model freely. And we also have the actions, and actions can be of two types. One type of action act on the domain layer to change data, create objects, delete objects, change attributes, etc. Another part of the actions may be to navigate the current shown view, or let the user jump between views, jump between perspectives. And of course we have the stream of information from fetching data that goes from the database into the domain layer, and the updates that goes this way. This is protected by transactions, SQL Server transactions, database transactions. And the domain layer offers the user to do multiple changes on the information and decide if it should be saved or not. So that's one good effect of having the domain layer, that you could do multiple changes and see the effect without committing to the database. And of course this domain layer is one per active user of our application, so there will be many doing these operations against our single database. And as views or domain model view models concerned, these are also many, even per user. So each user has multiple views typically to look at and to jump between. The domain layer strategy allows us for implementing a lot of important features like the undo and redo stack of information that's available on change information that hasn't been updated yet. We have the derivations of attributes and associations here, calculated things that are very efficiently handled in the domain layer. Yeah, so this is basically what we offer with the standard MDriven framework. In MDriven framework you get this domain layer in C#, and you can develop and code against all the information available here, defined here, with the strongly typed C# code. Yeah. Further things you add to the domain layer are constraints, and I don't know what I should say here. Yeah, constraints and the access groups, and the in-memory transactions are important things as well, because when you code with C#, you might have an operation and in the end you find that some criteria isn't fulfilled. Then you throw an exception. Then you want to roll back all the changes that the operation has done. And in-memory transactions that are different from the database transactions. In-memory transactions are a beautiful way to reduce the unnecessary or reduce the code that you need to write to handle checks on business rules, for example. All right, moving on. In the view, or really all the things in the domain layer, any given attribute on a class or thing or a list on a class or subscribe or publishers. So what I mean by that is that they follow the subscribe and publish pattern. This means that every publisher can have a subscriber. So if we have a view over here that looks at some value X that really is this one, it also has a subscriber for that. So whenever this attribute is changed, a flag is set on that subscriber to say that's invalid. And if we have some derived thing that also watches this by a subscriber, a flag is set to say that it's invalid as soon as this change. Of course, this one might subscribe to hundreds of things. So whenever something changes, it will be invalid. When it comes to derived attribute, and derived associations. We wait to do anything about this invalidation until someone reads it. So the first one reading this one, finding out that the flag is set, will also recalculate it. This is a very efficient way that MDriven framework manages derivations. When it comes to UI, there's typically a continuous loop going, checking the subscribers for invalidation. This is to the MDriven framework developers known as the display loop, because a user that looks on this can't really trigger the reading. The user just expects it to update. So if we had another UI watching the same attribute, as this is changed, the subscriber is highlighted, and also this subscriber is set as invalidated. The display loops runs, and then it asks this one again and say it's X. So that's how the MDriven framework works, and how you can bind to everything in the domain model. So I haven't really touched upon how Turnkey makes use of this, but this is all very important for Turnkey, and Turnkey makes totally relies on these mechanisms. What Turnkey does is to, once we have this ability, we can instantiate the information hierarchy that is the result of the view model definition. So you will have on the server side in Turnkey an information hierarchy that's implemented by the VM clause. So that's a view model clause. So that's the information hierarchy with the attributes or other view model columns and view model nestings. And since these subscribe to the things in these papers here, so you see, since these subscribes to all the things in the domain layer, they will be updated as needed, just as I described here. So this one stays. Okay, short intermission because the camera had frozen. So everything here will get updated by this mechanism when any information changes. And as this gets updated, it also maintains a command list. So whenever anything is changed here, a command is added, lost in the list. So all the attributes changes end up as commands here. And all the commands has an integer number starting at 0 and down to X. And if someone changes anything, that would reflect on a change here. It will add a command lost. And what also happens is that it checks up in the list to see if this particular attribute has earlier commands. If so, they are removed, because there's only need for the last command. And what we then do is we expose an interface, a web IPE call on the MDriven Turnkey server that is called updates with a parameter called cursor. So the cursor is actually the number in the command list. So if you ask for cursor equals 0, you will get all these commands. And they will be delivered to you in a list, a JSON list, as JSON objects. Right? So, as this list of commands is maintained, we have a client. And on the client we have a piece of logic. Okay, so sorry about that, we had a camera freeze again. So we were here, we have a piece of logic that has the cursor value, asks what are the changes since the last cursor value, it gets the commands back, it interprets the commands and build up a hierarchy based on the result from the commands. And this hierarchy will in time be exactly the same as the server side hierarchy, but of course maybe in a different language and everything like that. So this is a separate piece of logic, totally separated from the server. And on the client we can of course build a UI and that bind to the local information hierarchy like this. And as this is updated, the UI will update as well. And if the user changes something here, it will we have a client-side logic to detect this and build up a small client-side changes list that really or commands that this logic, whenever it's about to do its thing, sends all the outstanding client commands back to the MDriven server, another interface that we call client updates. And the client updates are interpreted as changes to certain things here. And since this is backed by an expression that will update something in the domain layer and trigger some subscriptions and come back as updates to the information hierarchy, possibly if there's a derivation depending on this, that will in turn end up as commands in the list and new commands in this, and that will be caught by the loop here, asking for anything that changed since the last cursor value, and the hierarchy here will be updated. So that's pretty much it, unless you have an action here. Let's say we have a button here that says add. This is not a standard attribute change. Instead it enters a command here that states which action should be executed, and following the normal route it comes here, gets interpreted as an action available here that does something or navigates or whatever. As it has done its stuff to the domain layer, in this case I guess it was add on a particular relation, it will create a new object, and since we have subscribers watching this association, it will invalidate this and will update this when needed. So a new row will be created somewhere here that will in turn end up as a command that we should insert a new row that will end up here, and we will have a new row here, and then the new row will show here by data binding. Right, so that's pretty much how it works. We did this logic is fairly straightforward and simple. There's actually nothing MDriven to this. This make use of none of the central assemblies from here. This is completely standalone. It's in two incarnations, one made with TypeScript, JavaScript, and it uses Angular JS for the binding things, but it makes an information hierarchy that you can bind to with Angular. I guess you could use any other web thing as well. I'm not sure. And we have the other one, VPF. We call it VPF because this thing of ours use VPF, but it's really C#, and you could use this part with Xamarin to make Apple products or whatever, Android things. But we haven't done this part, the automated UI for Apple or Android. This is actually backed by another interface that it's an IPE here that's really easily gets the information needed to build this part of the application. So having said that, you could reuse everything of the MDriven Turnkey stack straight from the database to magically have the information hierarchy available to you on the client side without any trouble, and all the changes that normally goes along with developing an information systems will be handled in seconds, right? So you can do all of this, and what most people react to is this part, the VPF or Angular UI. And of course you are free to build your own. You can do UI overrides, and then you would roll your own, just like you roll your own today, but you will bind against this information hierarchy, which of course is a perfect definition of a perfect implementation of the view model definition. That's easily available in a web IPE call, right? So don't let this thing stop you. If you don't like this, or if you want it to do in another way, sure. Just don't throw out the infrastructure to get information to the client. And you get information to the client in a very secure way, because there's no logic, no information here available other than the one information that you define here. So you have already decided that the user is supposed to see this, and that is what the user sees. So if you were building an internet bank or an insurance company or some high level financial instrument thing that you really need to secure, this would be the perfect infrastructure and architecture. You can even have your clients, if you're a bank, you can have your bank customers build their own clients. It's that secure. There's no way to go beyond these interfaces with the attributes and actions that you already have exposed. So there's no danger in having your bank customer doing their own application. That's probably never going to happen, but it's an important principle. Okay, questions on this? I don't know. But I'll be happy to answer any questions on why we did this in such and such a way. And just email or send us on the forum or something like that. Thank you for watching, and hopefully things are a little bit clearer, or at least confused on a higher level. Thank you.